There is substantial evidence suggesting that billions of years ago, an asteroid collision may have delivered the essential ingredients for life to Earth. Over time, additional asteroid impacts contributed key elements that aided the development and evolution of life. However, not all asteroid collisions have had beneficial effects. One such impact is believed to have triggered a mass extinction event, wiping out a significant portion of life on Earth. Despite these catastrophic events, our planet has remained a thriving home to diverse life forms for billions of years. While humanity certainly wishes to avoid future asteroid impacts, their movement remains beyond our control. Numerous asteroids in our solar system have the potential to cause severe damage if they were to collide with Earth. Although many pass close to our planet, none have yet posed a direct threat. Scientists continuously monitor asteroids that could become hazardous in the future. By studying their trajectories, they aim to predict potential collision risks. Yet, what if our understanding of asteroid movement is incomplete? What if an unknown force is subtly influencing their motion? Recently, while analyzing an asteroid's path, researchers made a startling discovery, raising concerns and prompting them to closely observe an asteroid called Apophis, which is expected to pass extremely close to Earth in 2029. But what exactly did scientists uncover in their recent study, and why is Apophis' approach so concerning? A discovery that changed everything. The story begins in 2023, when a spacecraft returned to Earth on a bright morning in the Utah desert, completing one of the most remarkable journeys in human exploration history. Having traveled over 2 billion miles, it carried a capsule containing precious material, rock and dust collected from an asteroid named Bennu. Measuring just 500 meters in width and shaped like a spinning top, Bennu serves as a time capsule, preserving secrets from the formation of our solar system over 4.5 billion years ago. Scientists believe Bennu contains primitive compounds, including organic molecules, that may have played a role in the emergence of life on Earth. In October 2020, NASA's OSIRIS-Rx spacecraft landed on Bennu's surface, collecting material that could provide insight into the building blocks of our planet. The data gathered from this mission has already proven invaluable to planetary science. Among the researchers analyzing Bennu's trajectory was physicist Udi Sai from Los Alamos National Laboratory. While studying its precise orbit using data from OSIRIS-Rx and previous ground-based observations, he noticed something unexpected: anomalies in Bennu's motion that could not be easily explained. Sai questioned whether an undetectable force, too weak to measure directly, was subtly altering Bennu's path. His team's research suggested that tiny, almost imperceptible deviations in its orbit might hint at the presence of an unknown force. In science, unexpected anomalies in celestial movements have often led to groundbreaking discoveries. The invisible hand in space. To illustrate the mystery, imagine playing a game of billiards, but instead of the balls rolling in predictable straight lines, they veer slightly off course, as if nudged by an invisible hand. You might suspect that the table is subtly tilted, even if you can't see it. In a similar way, scientists studying Bennu's trajectory observed unusual patterns that suggested an unidentified force might be influencing its motion. This revelation is alarming because it exposes gaps in our understanding of how celestial objects move. If our models contain inaccuracies, predicting asteroid paths becomes even more difficult. With Apophis set to make a dangerously close approach to Earth in 2029, these uncertainties are particularly concerning. On April 13, 2029, Apophis will pass within just 20,000 miles of Earth, so close that it will be visible to the naked eye in certain regions. Although current estimates suggest it will not collide with Earth during this pass, even minor miscalculations could have serious implications for future encounters. Measuring approximately 370 meters in diameter, Apophis has been under observation for years. However, recent discoveries have heightened concerns about an increased risk of impact. The newfound evidence of unknown forces affecting asteroids has made tracking Apophis even more critical. Scientists plan to use its 2029 flyby as an opportunity to analyze its trajectory in detail, better understand these mysterious influences, and refine their ability to predict its future movements. A new perspective on Apophis. In another groundbreaking study, Canadian astronomer Paul Watt challenged previous assumptions about Apophis' orbit. His research suggests that there is a small yet noteworthy possibility that the asteroid's trajectory could change, potentially directing it toward Earth after 2029. This unexpected revision has sparked intense debate among scientists. Watt's findings indicate that even a minor collision with space debris or a small asteroid could significantly alter Apophis' course, possibly putting it on a path toward Earth. Using computer simulations, his team assessed the likelihood of such an event occurring before Apophis' close approach in 2029. Their analysis revealed that even a small object, just 0.6 meters in size, could potentially push Apophis into a keyhole region, a specific gravitational corridor that might lead to a future impact. However, the probability of this happening remains extremely low, estimated at less than 1 in 2 billion for 2029 and under 1 in a million for a later collision. Even if such an event were to occur, only about 5% of these possible collisions would shift Apophis onto a direct impact trajectory with Earth. In other words, the overall likelihood of an asteroid altering Apophis' path in a dangerous way is still below 1 in 2 billion. Though these chances are exceedingly rare, the study underscores the unpredictable nature of space. Even minor cosmic events can have significant consequences, reinforcing the importance of continuous monitoring, not just of large asteroids like Apophis, but also of smaller space debris that could indirectly pose a threat. Preparing for the unknown. Apart from Apophis, scientists are also monitoring other asteroids that could pose a risk to Earth in the future. One such asteroid is 2007 FT3, measuring approximately 340 meters in diameter. It has a 1 in 11.5 million chance of colliding with Earth on March 3, 2030. Meanwhile, NASA recently conducted a hypothetical exercise to evaluate global preparedness for an asteroid impact scenario. The simulation involved an asteroid that had previously gone undetected due to its orbit around the Sun. According to the exercise, this asteroid, large enough to cause severe regional devastation, was projected to strike Earth in 2038. Participants were informed that its size ranged between 60 and 800 meters, and that there was a 72% chance of impact. However, only 6 months before telescopes could provide more precise data, the asteroid was predicted to move behind the Sun, making it impossible to observe for a crucial 7-month period. This exercise highlighted several major obstacles in planetary defense. One of the biggest concerns is the current lack of capability to deflect or destroy an asteroid on short notice. Existing technologies, such as kinetic impactors or nuclear interventions, require extensive development and testing, often taking years before they can be considered viable solutions.